Okay, so in Wireshark, we see a whole bunch of messages. So here's ARP, here's OSPF, CDP, bunch of protocols being sent on the network. But I'm going to filter for OSPF. We've got two routers. This is router 2, this is router 1. So let's have a look at router 1 first. So router 1 is the router on the left-hand side. Frame is IP version 4 from this MAC address, sending a multicast to the well-known multicast for OSPF. The layer 3 protocol referenced here is IP version 4. So at layer 3, we see IP version 4. Source IP address, destination IP address. Protocol number is 89. That looks good. That means OSPF down at the bottom here. So let's have a look at OSPF. Look at the header. The version is OSPF version 2. It's a hello packet. Router ID is this. It's got a backbone area. Password is set to this. So that all looks good. So let's have a look at router 2. See if we can see a difference. That all looks great thus far. So we can't see a problem there. Let's have a look at the hello packet and see if you can see a problem right away. What's the problem here? Can you see the issue? Notice this mask is different. Now for OSPF routers to form neighbor relationships, they have to use the same subnet mask. This IP address on this side is set to 10.13251. On this side, it's set to 10.13252, but notice the network masks are different. If the network mask is different, they are not going to form a neighbor relationship, which means they're not going to exchange routes, which means it's not going to work. So what I'll do here actually is start a new Wireshark capture so that you can see what it looks like once things are fixed. So OSPF at the moment, we are seeing the problem from the original Wireshark capture. So in the header, let's have a look at the hello packet. Notice the masks are different masks over here. So what I'll do is have a look at these routers. So there's router 1. And here's router 2. Okay, so router 1, router 2 have booted up. Show IP OSPF neighbor. Notice no neighbor relationship. Show IP OSPF neighbor. No neighbor relationship. Show IP OSPF interface brief. We can see that OSPF is now running on 3 interfaces. A loopback plus 2 physical interfaces. Show IP OSPF interface brief. Same thing on this side. So in the OSPF captures, you'll notice that the loopback address is used as the OSPF router ID, even though the IP address that's sending out the multicast is the physical IP address on the interfaces. So notice router 1 has this loopback, router 2 has this loopback. That's fine from an OSPF point of view. But if we have a look at the configuration, and let's do it this way, show interface or IP interface gigabit 01 on this side, and on this side show IP interface gigabit 00. Notice the subnet masks are different, /26, /24. Show run interface gigabit 00, /24 on this side. Show run interface gigabit 01, /26. So on this side, interface gigabit 01, IP address 10.13251, 255.255.255.0. Hopefully, once that happens, if there are no other problems, the neighbor relationships should be formed, and there you go. Notice loading is set to full. So show IP OSPF neighbor. Neighbor relationship is up. Show IP OSPF neighbor. Neighbors are up. Just make this a bit bigger. So neighbor relationships are formed between the two routers. Show IP route. We see OSPF routes in the routing table. That looks good. So if we go back to Windows, they should hopefully be able to ping each other, which they can. The two Windows PCs, PC1 and PC2, can now ping one another. Remember, in OSPF, the subnet masks have to be the same for the routers to form neighbor relationships. If the subnet masks are different, they won't form a neighbor relationship. Hope you're enjoying these troubleshooting videos. It's important that you know Wireshark. It's important that you know your protocols. I like to say that the best way to learn is to troubleshoot. And Wireshark is a great way to actually learn what's going on, not in theory, but in practice. This is like running a real physical network and capturing the traffic. You can actually see what's going on.